Okay, so here is the Alpha Juno 2. Now, this one's condition's better as in terms it hasn't been dropped, but it's really dirty. So when I received it from the buyer that had shipped it, it came in this soft travel case. It had foam inside, and the foam had been completely deteriorating. So it's stuck all over the keys everywhere, and it's actually pretty nasty. I wiped some of it off when I got it, but I just left it for then. Even the vents in the back are kind of all stuffed, folded, and stuff like that, so I'll have to clean that out from there. Two, this has definitely been more heavily used than my Alpha Juno 1. The membrane keypad's pretty worn. It actually starts to turn kind of glossy just from the usage of people pressing buttons and stuff like that. So the front panel doesn't look as nice as a result, but it's strictly just cosmetic, functional. It still works. I tested all the buttons there. I know that they're working, so we'll be fine there. Now, when I did power this on previously, there was a section of keys that were dead somewhere in here. So it was. So this whole block in here, I'm going to mark it just so I remember. Okay. So everything in there is dead. Typically when you see a block like this, it's an addressing issue where, you know, these are broken into sections of addresses like a matrix, you know, between, you know, you've got your rows and your columns essentially, except for it's spread over the entire key bed there, and that's how you address out your key presses. So when you see a chunk like this that's dead, it's usually not the key contacts. It's usually something electrical. So one of the wires coming off the key bed that, you know, could have an issue or something like that. We'll dig into it. But typically it's not contact related when you've got a whole section of keys like this that are dead. When you've got kind of random keys all throughout, and you know, keys that are more heavily used, you know, or start to wear, you get a lot more use. You'll find that section usually is a little bit more dead. But in this case, because it is all sequential, it leads me to believe that's just an addressing issue. So we'll take a look. Always prop it up on foam or something, because you don't want to put weight on the pitch bender. You don't want to put that force of it sitting upside down onto that potentiometer in there. That's usually what causes them to break. So as I'm disassembling this, I stopped the video, brought the camera over, because I appear to have found the culprit, or at least possibly. So this connector was here. On the Alpha Juno 2, you've got to unplug some cables as you flip this up, because they're not quite long enough. And if you look, you can see it's pretty frayed right there. And the reason for that was it was actually up against this piece of metal right here, which was screwed into the base, kind of pinching it in place right up against it. So that may be part of the problem right there, because these three cables right here come off the key bed, line up to the connectors here, and this is what I was talking about in terms of the matrix, in terms of the addressing the actual key bed. So I'm willing to bet one of those wires right there is probably short or open. Okay, so inside the Alpha Juno 2, a couple things that caught my eye right away. Number one, this connector and this pin, as I mentioned, that's not right. I have a hard time believing the manufacturer would have done that and pinched that in there. Number two, this cable is all mangled. Like, it's just torn up. Like, it was not routed properly and just kind of jammed back in there. And I mean, I haven't seen any issues with this, so I'm assuming the cable's still okay, but I don't like it. Number three, this battery. So I've never seen this style, the BR style, you know, 3-volt lithium in here. It's always been the, you know, CR2032 button cells with the tabs. The other funny thing is, it's not even soldered in. Like, this pin over here is soldered in, but this side's not. It's just moving. So it's fine. You replace it. I mean, it's a replacement. You can replace with that. There's no issues, but solder it in at least. Anyway, I think the issues with this are self-induced from somebody else doing a repair on it, of replacing that battery, and that's why our issue is here. I'm almost guaranteed that this crimped or this broken connector here, I mean, that one wire almost looks cut. So we'll see, though. I'll test. This might be a broken pin on here too. I got to take a closer look at that. I'll probably pull this board as a result. So a few other notes. First of all, this thing did take a hit. It must have been dropped. Not terribly, but the back corner here took a hit. Let's see if that's on camera or not. A little bit. You can barely see it back here, but this is bent. And secondly, there's a broken piece just kind of floating around up here in the chassis. I don't know That's part of the Keybed support. I'll have to look and figure out where that came from. 2, there's that foam I was talking about, and the entire thing's just filled with it. I gotta get a vacuum and vacuum this whole thing out because it's just everywhere and disgusting. Here's the power supply. It's the same as the Alpha Juno 1. I'll probably just recap it like I did the other for good measure. We'll take a look at those caps too. It looks pretty much identical. So main board, back here on the Alpha Juno 2. You'll notice it's a little bit different design internally. The board on the Alpha Juno 1 was sitting here on top of the Keybed, which is good and bad. You don't have this wire folding issue when you actually try to open and take it apart. But at the same time, if you did have to work on the Keybed on this unit, there's nothing in your way blocking you basically from moving this out and working on it, which is really nice. It makes servicing this synth a lot easier in that regard. I don't remember if I mentioned or not, but the Alpha Juno 2, the Keybed is also semi-weighted. You can see the metal little pieces of steel here glued into the actual bottom of the keys. So this was pre-Roland using nasty red glue too, like you found on the JV80 and a couple other synths in that era, where the glue would just deteriorate and get nasty and basically destroy the synth. These look to be in pretty good shape in terms of the glue. It's like a clear, some type of clear adhesive they have in there. So back to this wire, you can see right here, these 3 specifically are pretty frayed to the left. And my new theory is that it doesn't look like they're broken. It looks like they're still there, but I'm curious if they were actually just shorting out, resting against this piece of metal right here, which you can't see right there. So the placement of that board puts that right about here, and that's where the wear was actually coming from, rubbing on the side of this metal. And I'm betting the one pin for that section of Keybed there, the wire was actually shorted out, which is why it wasn't working. So my guess anyway. We will know once I power it back up here. Now looking back at this battery, you can see that this side of it's not even, I can't tell what they did here. I'm assuming, it's only the 3 screws that hold this board in. It's not hard to get it out to replace the battery. So just bad solder joint potentially, or just over time vibration from this thing flapping around that just broke the side of the joint free. Either way, I'm taking that off. I'm going to put the right cell in there because that's just silly. As for this, like I said, the wire's not broken. Ideally what I should do is pop these pins out. They'll come out just by putting a little bit of pressure on that tab inside the connector and then pulling the wire. Usually it goes pretty easy. Of course I can't get it on camera. There it goes. Okay. So I'll pop those 3 out. What I may do is strip that wire back, reinsert it, solder it in there, and then put these pins back in. I just don't like the idea. They're not broken now. I could tape it, just reinforce it, but I'm just worried they could potentially break in the future. Okay, so the wires are definitely not broken. They're really small, and it's going to be hard to get. They're almost crimped. They are crimped on there. So I'm just going to tape them. Tape them carefully. Put them back in. Okay, the 2 that were worse there, they were actually shorter. They're taped up. The rest don't have any wiring exposed through them. I'll wrap some tape around the whole connector too, just in case it rubs on here again. Again, I'm going to route it correctly, figure out why it was pinched between there, but I'll make sure it doesn't happen when I reassemble. But I tested continuity, I wiggled it all around, it's solid, so I think that'll be fine. So here's the battery that was in there. It's your BR 2/3 A 3-volt lithium. You see this in quite a bit of gear actually, both in the terminal type, where you solder it in, and also a few times I've seen them where they're socketed. Not too often though, but I've actually got a bunch of these new because I see them quite a bit. But for this device, this is the correct battery you're supposed to use. So in this case, it's made by Panasonic, 3-volt lithium, equivalent to, basically a CR2032 size. DigiKey part number P666-ND if you want to order one. They're only a couple dollars, they're not expensive. So I will put this cell into this unit. Make sure you get polarity right. Top pin is always the positive on these cells. So what I'm going to do is reassemble it now just enough so I can test it and see if the keyboard issue has been resolved with the the cable basically not resting on that metal base there. Okay, I've got it flipped back over, just kind of up on some foam. It's just sitting here, and just so I know nothing's touching. I don't have any screws in this right now, but we will power it on. Power's on. I got the check battery message. So that's actually good that came up, because I can show what the reset procedure is to reset one of these if you have to replace the battery. So first thing to do is make sure the memory protect switch in the back is set to off. That is, memory protect is not on. After that, turn the unit back off. What you want to do is you want to hold the portamento button, which is just off camera here, and the data transfer button, and then power it back on and hold those. And you'll see it says initializing function RAM, and that brings it back to a working state at this point, which is good. So there's one more step you need to do as well. So power it back off. And this time you hold the key transpose button and the portamento and power it back on. And you'll see it says copy preset to memory. What that does is it's actually just taking all the presets and copying them back over to memory, because all the memory area space was gone anyway since I removed that battery and put a new one in. So this way, instead of memory just being blank, you've got all the sounds in there from the presets. So question is does it work? Going down to my dead keys. Ha ha ha, still doesn't work. Okay, so it is more than just that cable being pinched and possibly short in the ground. So I'll have to dig into it some more at this point. So I've got it propped up right now where I can kind of at least work on it. I'm able to access the front panel back here if I need to. I can get to the back of the keybed right here where it's propped up. I can power it on and actually hear audio out of it. So I'm still not getting audio out of there, even though poking around a couple more wiring harnesses and things like that. So I think I do want to take a peek underneath these keys right here and take a look at the keybed area. Just make sure that there's no water damage, nothing was spilled in there, etc., things like that. Dental tools are great for getting these springs on the keys off. You kind of hook it in there and pull, and then rest your finger on it. This almost guarantees you that this way it's not going to go flying off the room somewhere if you lose tension of it. All the springs on the Alpha Juno 2 are the same, which is nice. There's not different tensions for the white and black keys, so you don't need to worry about mixing them up when you take them off. So I don't see any water damage, which is good. But it also means I'm probably going to have to pull a lot more of this keybed off to figure out what's going on. Okay, I had to dive in this a little bit deeper because things weren't making sense. So one thing I noticed was... Here, is it on? Let me turn it on. Alright, going through the keybed, there was one more key I missed. So this key right here was not also not working. So I missed that during my initial run through. So I'm like, well, that's odd, because we got the chunk right here that is obviously has to do with the array that the way that the key presses are addressed. So the odd thing about that was you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So typically when keys are out, I didn't notice that initially, but usually in the groups of 8. But I've got 9 here. So there's this last key that's out for some reason, and the ones beyond that, I've got this just lifted temporarily. But the ones beyond that are not working. Or are working. And then you drop all the way down, you've also got this key. Again, 9 more down on that same address bus. So I started asking myself, okay, well, so just checking continuity, I went through, turn off, and this is that blue cable I had issues over there, and I went through and actually verified I got connectivity on every pin going through here, which I do. So I know that my connectivity, from that to that is good. And then I did the same thing for the green or the orange cable right here going to this header, and I know I got connectivity there. So looking at the keys that aren't working, so I've got this initial bank right here, which is addressed through this chunk, and I can verify that I've got that all the way back to the blue connector there. So I know that this address section is working. That's for the 8 right here. And I've got one more key, the 9th, on this bank, which ties to this one, and it is also just fine. So on the top side addressing there, going to the blue cable, I know everything's working. On the bottom side, I started doing the same thing, but I noticed that based on those 9 keys that were out, and they all follow along the same path, so you got this one, this one, this one, I knew that there had to be something up with the addressing along the bottom here. And sure enough, if you look This second key right here goes through this bank of diodes and connects to this bottom trace on this board. Runs across. You've got the second one here, that ninth one over, that falls through this diode group of diodes right here, which also falls to that bottom bus. And then the last thing happens over here as well. You've got that group that's going through these two diodes in the bottom bus. So scrolling along, well, first I'll just show that I don't have any continuity between those yet. I have them between each other, but not back to here. So looking at the trace right here, something must have spilled down there because the I'll pull in the camera closer, but the silk screen's falling apart right there on that trace. So that trace is bad. And then looking in this region right here, I've got the same. It looks like there's 3 or 4 traces right in a row, all tied to this group of keys right here that are also bad. So these couple traces right here are why this entire group of keys is not working. Here's a close-up of those traces. You can see them. There's ones right here. It's kind of, I scraped it a little bit apart, and you can see the same right here, where there's just something eating away at those, and they're not making, you know, continuity across. And again, I'll check it here. I got nothing. So I'm gonna have to just repair those. I got some wire wrap wire I'll use, and I'll solder it across and glue it, and then, you know, bring it up to these pads here. So I've got the first bad trace repaired, which was there's a break in the trace right here. So I ran this wire across the board here, bridging basically across that trace where it's dead. And in doing so, I've restored functionality to the 9th keys all in the row that were affected by that bus. So that's working now. But this big section of 8 right here is still dead. So looking at that, what you want to look for is, you know, basically the buses that connect all of these together. So the first obvious one is the upper section here that connects all these together from this pad here. So I've probed that pad right here, little test point, all the way back, basically all the way back to the board here, and I've got connectivity, so I know that's fine. So the next one you want to look at is, let's see, it's this lower section here from the velocity stack where they all kind of merge into this row right here. And with that, there's a test point here and then a test point up here, which does not have connectivity. And looking at the trace right here, you can see it actually looks like there's a break here and potentially right here. So I'm going to jump a wire across this, and I'm betting that's going to resolve that section there. So I got the second wire ran. There was really no good place to solder it over here. I didn't have a pin like I did for the upper section, or the lower section here. So I scraped a little bit of the trace off on this area, which is known good. Put some solder there, and then brought it around and over to the pin over here, where it jumps off the board. So I'm going to epoxy this down so it doesn't move around. It'll look nice when it's done. But as a test, just set that back on. So, yep, that was it. We got full functionality back. So that's what the problem was. So again, there's some questionable areas of the traces in here I found. I don't know, I mean, this is directly exposed between the keys, so if any liquid gets down in between there, it's going to end up right in this board. My guess is something got down there and corroded some of these traces just a little bit. It's not uncommon. You see this occasionally. But that's the best guess I have of what's happening here. So like I said, I'm going to epoxy these down. And since I'm already this far into the keyboard, I've already got half the keybed taken apart, I'm just going to take the rest of it out as well and just inspect and just make sure there's nothing over there that looks questionable on the board itself. And that will give me access to clean all the rest of these keys properly too, because the keys themselves are pretty nasty. And when they're out like this, you have a really good chance, or you have a really good opportunity to clean the sides, really clean them up, make them look nice. So it's not much more work to pull that, so I'm going to do that as I continue going through this. So it's the next day, and just continuing on the Alpha Juno 2 here. I've got the wire glued down, so I've just got it epoxied around and routed just out of the way of everything, so there's no risk of breaking it there. So this is all done in terms of the wiring there. So here are the keys, all nice and clean. I took these all out, I cleaned them all separately, that way I was able to give them a really good clean. They look really, really nice. I just used some warm soapy water, a soft sponge, and then microfiber cloth. Always use something soft when you're drying these, and attempt to clean them. That way you don't scratch them. So it is really the best way to clean these is to remove them from the synth. That way you can get the sides. It's just easier that way, especially if they're really dirty. So next steps is reassemble the keybed. I won't film that because it'll be pretty boring. Then when that's done, there'll be a couple of last little things I want to look at on this synth. So Keybed's good at this point. The next item I wanted to look at was the main board here, specifically with the firmware. So in my previous video on the Alpha Juno 1, we talked about the firmware briefly, and if you remember, that board actually had a soldered-in EPROM because it was at the latest version of 2.4. This one obviously is specific to the Alpha Juno 2, and it's got version 2.2 on it. So I'm going to update this to the latest version of 2.4. So to do that, I'm going to just pull the latest version online, a couple resources I've talked about in the past. There's a website ran by a man named Vincent, dbwbp.com. He's got probably the best ROM archive out there for vintage audio gear. A lot of the stuff I have, he didn't have, I've submitted up there as well. So this is a 27128. So I've got another one here that I've already UV erased. I will burn the 2.4 version to this and replace it. Okay, so new EPROM is installed with the 2.4 software. So I will gently turn this back over and power it on. And it works. So this is how you update the firmware on the Alpha Juno. A couple notes on this too. I misspoke earlier. I said the latest version of this was 2.4, when in reality, as far as I can tell, is 2.6. Although the latest version I could find was 2.5 in terms of the ROM, so that's what I programmed into here. Now, you can buy the version 2.6 I've seen out there, which annoys me. So if I ever come across version 2.6, I'll upload it to the couple resources I mentioned before, just because it's ridiculous that some of that stuff is out there and people want silly money for it. Two, the Alpha Juno series actually has the assembly available for the actual firmware that's on the EPROMs. So there's been some people out there that have done some custom modifications to it. I'm not going to install any of those on here just because it's not necessary for the purpose I have of the synth, but I just wanted to mention that there is the assembly is out there, so if anyone is interested in modifying the actual ROM for this for any certain features or any bugs or additional things they want to have fixed for it, it is possible to do so, which is actually pretty cool. You really don't find that very much from any Roland gear as far as I know. One last thing I wanted to mention was you can actually view the firmware version you have on your unit without opening it up. To do that, you hold the portamento button and the mod rate button and then power the unit on. You can see here it's not completely descriptive, but mine says version 4.3 February 12th, 1986. So at least I think that's the date for the code of the actual ROM that I have replaced. So while it doesn't tell you the version that's currently in there, which in my case is 2.5, this text indicates that it is version 2.5 that's currently on the synth. So if you see this, you know you have version 2.5. I believe some of the older versions will actually have the version number on there. So if you have version, say, 2.1, it'll say 2.1 on the actual display. But just to know, if you see this, then you know you have version 2.5 installed in the synth. So remaining steps for the Alpha Juno 2. First, I vacuumed up all that crap that was in there, so I got it pretty clean right now. So cleaning will be and has been a big part of this. Two, the little piece of plastic I found floating around in there was actually part of the stand for music sheet music on the top there. So I glued that back in place. I still got to get the other one, which is loose over there too. So those are back in place. Three, power supply. I talked about this pretty in depth in the first episode in the Juno 1. I rebuilt power supply, replaced all the capacitors. I'm going to do the same here. Again, like I talked about in the first episode, you don't need to really do this time. These power supplies are actually pretty good. They've got reasonable quality caps in there. I haven't seen any of these leak even at the age, but they're really nearing their end of the lifespan. So you're going to have to start replacing these at some point soon in the future. And since I plan on keeping this synth for quite some time, I'm just going to do it now, get it over with. There's only 8 of them on that board. There's not a lot, and that'll guarantee I don't have to deal with it moving forward in the future. I did want to talk a little bit too, just real quick, about the main board in the Alpha Juno 2. I talked about it in the Alpha Juno 1 episode that it was very different between the two. I'll throw a screenshot up of the two boards here comparing them in case you haven't seen that first episode. So you can see the form factor is, roughly the same size, but layout is completely different. So there's a little bit more digital logic going on for, like I said, the velocity, the velocity keybed on here, and be able to calculate the timing between, the two pads on the keyboard for that. But beyond that, the left side of the board, the analog side, they've actually moved off completely to another daughter board over there, and that's where your final op amps and your chorus lives, over on that board there. So it no longer lives in this board. You can see Roland Alpha Juno 2 is labeled on the board here, so this was only used for the Alpha Juno 2. It wasn't used in the Alpha Juno 1, obviously. Other than that, the boards pretty much use the same components. They both use the same CPU, they both use the same sound generator chip, which produces all 6 voices of polyphony. You've got the same IR3R05 filters on this that you do on the Alpha Juno 1. And then you've got the same chorus chips, even though they're off on the other board here. The classic Mitsubishi MN3009 bucket brigade delays, analog delays, basically. Just curious, trying to understand when this synth was made as well. So looking at some date codes, we've got 44th week 85. We've got, let's see, 46th week 85. 39th week 85. So sometime around late 85, possibly early 86 was when this synth was actually built. So I want to talk about the LCD in the Alpha Juno 2 here. So in the Alpha Juno 1 video I didn't really talk very much about LCD replacement because the LCD in that was still good. Specifically, the backlight was still bright, no issues. It was fine. I wasn't going to replace it. In this synth, though, the backlight is a little bit dim, so I am going to replace it. So LCD sits right here. It's easy to get to on the Alpha Juno 2. It's not buried behind the main board like it was on the Juno 1. It's a standard Hitachi HD 44780 compatible display. Nothing special about it. It is, an older version where it has the EL backlight that's driven from the high voltage supply off the main power supply. And that's what these two black and white wires are here. Now the older displays like this, and you can still get them like this today, they use the EL backlights. So on this display specifically, or on this synth I should say, the display itself usually doesn't go bad. It has, but typically it's just the backlight that goes dim. And to replace the backlight, you can actually just replace the EL strip, in the back of it with replacement, strips here. I don't have one the exact size for the display, but you can buy these. They're $5, $6, sometimes cheaper depending on the size, off eBay, other sources. And that's all you have to do is you can replace it. I'll show, but this little EL strip can slide out of there, solders onto those two pads there, and you can replace it. Now you can cut these too down to size. I generally don't like to do it because a lot of times they will bleed and not work, and you have to be careful how you do it too. You can't just cut it anywhere. You got to cut it only on certain sides. Typically these, I think you can only trim the length too. I don't believe you can trim them, smaller size like this. I might be wrong though. I haven't tried on this specific one. But if you do have the right EL backlight size, you can just swap it out, replace it, and be done. For this though, I'm actually going to replace the LCD. So I've talked about this in other videos before. You can buy replacement LCDs on eBay for hilariously cheap. I mean, these are, I think, like $3 or $4 a piece, and you can get them all different colors. Standard, backlight, inverse backlight, which I really like, and I've talked about before, where, the display is actually dark and just the letters highlight up. You can get them in, like I said, different colors: blue, white, green, yellow, whatever you want. You can get RGB ones too, so you can really have truly any color. Anyway, I'm going to swap this out on this display. I'm probably going to keep it the same. I've got a white backlight display. One of them here. I don't remember. I got to go through, figure out which is which, and put the replacement in. Now these newer ones, the backlights are actually LED strips. They don't use EL backlights. So the strips in there, are similar to this. It's just an array of LEDs in there. So the good news is that you don't need the high voltage pins from the high voltage supply to run, the EL strip anymore. So you can just remove those wires, disconnect them, whatever you want to do. For people that have power supplies too that whine, where the high voltage transformer, there's, you know, got a ring to it. Usually it happens when the display is going bad, but sometimes they'll just ring because there's, you know, poor design transformer, whatever it might be. Regardless, going to a LED based LCD on here will actually make that ring go away, which is pretty nice. So here's the LCD itself. We will have to remove this connector and put it onto the new LCD module, and you can see they're the exact same size, and they even have the same mounting holes. There's a standard to these displays that makes them pretty universal repairable. I think I mentioned before, these are 16 character by 1 line displays, so just need to make sure you get the right one. And if you're buying the ones with the LED backlight, you need to make sure you get the 5-volt version of the display, not the 3.3 volt. So the last thing we'll need to look into is contrast. So there's a pin actually on the connector here which manages the contrast of the LCD display itself. Some sense that's controlled via software, and that pin's actually driven by a DAC somewhere on the main board, you know, so you can control the contrast from the front panel display. That's not the case on the Alpha Junos. There's a fixed, you know, voltage value on there that's, you know, that you need to adjust to get the contrast right. So after I swap this connector out onto this module here, if the contrast isn't there, I'll have to look into adding a small adjustable resistor, which you can just, you know, tack on the back, and that will allow you to, you know, adjust the contrast and get it correct for that display. So here's what I've done so far. I took the connector off the old display, which I've got here. So that connector removed, soldered that onto the new display, and then these 2 extra pins over here are actually the 5-volt supply for the LED backlight. They're also wired over here, but I just jumped them off the 5-volt power from the main board to here over to there to make the backlight work. So at this point, I can turn it on, and it works. I ended up just choosing the kind of the white backlit display there. It looks very similar to the stock display. I kind of wanted to keep it the stock look. Secondly, if you wanted to control the brightness of the display, you could just add a resistor to the power coming in there, air trim powder, whatever you wanted to do if you didn't want it this bright, a little bit dimmer, but it's not terribly bright. It's actually pretty nice. So, since it's working, the obvious issue though is, like I mentioned before, there's no display, and that's because the contrast is way off on this display, so we'll have to adjust that. So on this board, R66, let me turn this off, down here on the main board, which is right here, this controls the contrast for this synth. So it's hardwired contrast for the old display. They didn't need to adjust it. So typically what I do is I add, you know, I just bridge that resistor, so it's basically a short there, no resistance at that point, and then I'll add a small trim pot onto the back of the display right here. That way I can adjust the contrast. And what you're doing is, I believe it's the 3rd pin here on the actual display. That is what your contrast pin is for the display. So you're basically just making a voltage divider, and then you can tweak that and adjust the contrast for that display. So here is the pot I'm going to use. It's just a little 10K pot. Value isn't super critical there. I think I'm going to have a change of plan though. So what I wanted to do was mount this up on the display, and I actually wanted to, here's pin 3 that adjusts the contrast, and I wanted to cut that trace and actually intercept this between you know, the LCD and the pin coming in there. But the trace is pretty small, and it climbs pretty close on the display there. I'm going to have to take this apart to get it. It's just more kind of a pain in the butt. Alternatively, I could, you know, desolder this pin, fold it over, and do something there. It's just getting messy. So what I'm going to do instead is on the main board over here, that R66, I'm actually just going to remove that, and I'm going to put a pot in its place instead. I think that'll be easier. Typically, I like having it up here. I don't really want to modify the main board at all, but it'll be okay in this instance. It's a through-hole component. It's not surface mount. It'll be simple. Okay, so I've got the pot soldered in down here. Plug the LCD back in, power it on, and see, we still got nothing. Make sure that's in frame. Oh, it's out of frame. Adjust this. There we go. So that is how you replace the LCD, at least of this type. I'll throw a link up of the auction I bought from eBay. I've been buying displays from this place in China for years. Buy Display, I think, is the name of it. I mean, it's hilarious. These displays you can get shipped from China to the US for like $3 or $4. It's just completely silly. Anyway, reassembly's got to occur now. I've got one last little problem I have to deal with, which is with these new displays. They are a little bit thicker than the old ones, as you can see here. I didn't measure it, probably another 3 or 4 millimeters thicker. But because of that, it doesn't quite reach the screws that are on the front panel there. These are set a little bit back that it actually mounts to. So the screws that came out of here, these little guys here, aren't going to reach. So I need to see if I have longer screws for that. And if not, I've got some screws that are a little bit bigger. I might just have to drill and tap those holes a little bit larger so that I can get the screws that I have in place for that display. So I didn't have the right screws, but I had some screws that would work. They're a little bit bigger than necessary. They're longer than I needed to, so I just put some rubber spacers in the back to kind of push the display towards the front there, and it works. Everything's lined up. It all looks good in the front there. So here's the final reassembly. You can see the display looks pretty nice in there, so I'm happy with that. So here's the Alpha Juno 2 all back together, and everything on it's working. So tested every key, everything's good, every button works, memory works, so I'm super happy with it. It cleaned up a lot better than I thought too. It actually cleaned up pretty nice. There's still a little bit of wear on the buttons, but it's not too bad. Display looks great, nice and bright, and that's it. So I did want to talk about one more thing. I want to talk about the PG300 programmer really quick. The PG300 is pretty cool and really completes the Alpha Juno 1, Alpha Juno 2 in terms of functionality, so I wanted to discuss that. So here's the Roland PG300 programmer. Like most Roland synths from this area, they took their control surface off the synth and put it into a separate programmer that you could purchase. They did this for several reasons. One, it made the synth cheaper because it was less expensive to make and can compete with other synths that were gaining market share at the time, like the Yamaha DX7, for example. Two, it was another accessory that you could buy, so they would make more money by selling these. You know, it was good business for them. Now, these programmers are stupid expensive today, especially the original PG300s. You know, on eBay, the asking prices for them go for quite a bit of money. When they do sell, they usually go for several $100s. I mean, I think I paid around $300 for this one when I eventually bought it, which is more than I paid for both of the Alpha Juno synths combined, which is silly. Granted, they weren't in a great working state, but nonetheless, these are expensive. I mentioned before, too, there's aftermarket people that make programmers that are PG300 like replicas, essentially. They'll work with the Alpha Juno series, but you know, they're not made by Roland. They're like aftermarket programmers, but they're still expensive. They're hundreds of dollars. They're almost the same price point, if not more, than the original PG300 when you can find one. So that all said, you don't need this. The Roland synths, the Alpha Junos, work great with the Alpha Dial. You use them, you get used to them, you get fast. You can program it really, really quick, actually, with the Alpha Dial. It's just not as much fun, and it's not as fast as having the real programmer, obviously. So a couple notes in the program I want to talk about, specifically the oscillator section right here. So it's interesting because when you read the specs of Alpha Juno, you look at the spec sheet, you see it's a single oscillator. You go through the Alpha Dial adjusting parameters, it's not entirely clear what's going on. The picture that the PG300 shows you in the oscillator section helps make a lot more sense. So in the oscillator, again, single oscillator per voice, 6 voices, you have basically 2 waveforms that are summable. So you've got a square wave here, and kind of a pulse and square wave combination, and then a sawtooth wave. So you can select either one of these from either selection here, or have them both off for that matter, and they will basically be combined to the output. Now, one of these options for both, this one here and this one here, actually has variable pulse width. So you can actually vary the pulse width with these sliders over here for those 2 waveforms. So that gives you a lot, pretty powerful control for that oscillator as well. So then you also have a sub-oscillator. So a sub-oscillator is interesting because it's basically an easy way to get, more sound out of an oscillator, because all it's doing is taking the primary oscillator coming off, and then just through some logic dividing it down, in this case I think an octave or half octave, I can't remember exactly what it was, and then combining that audio to the output. So it gives you a lot more depth in the sound for basically almost zero cost, which is cool, which is why you see it on a lot of synthesizers. Now with the sub level, you can pick, to have it all the way off to, there's 4 selectable levels for how much of that sub oscillator you want to have combined with the main oscillator, the 2 waveforms there. Then you also have noise, 4 levels of noise. I can't remember if it's pink or white noise, but there is a noise option on here. So the point I'm trying to make is, even though they say the synth is a single oscillator, it's actually a very powerful single oscillator because you've got a lot of options in terms of waveforms to combine to go through your output. Besides that, everything else is pretty standard on here. You've got your LFO at the top, envelope. You've got, Roland loved this 8-parameter envelope that they used on a couple of their synths, which is pretty cool to have it on here as well. Filtering, your typical resonance, cutoff, etc. and then your chorus as well. So simple on-off option for the chorus, along with the rate that you wish to have that chorus on. So that is the PG300. Definitely a very fun programmer for the synth. I would definitely get one if you can, because it just makes the synth a lot more enjoyable to use. So this completes my repairs for the Alpha Junos. I hope these videos were beneficial to you. Again, these are really cool synths. You can get them very cheap. Classic Roland sound. Last of the actual real Juno series from Roland. So thank you for watching.